All right, good evening, folks. So we're continuing with rational functions. Today we're going to look at how do you write the rational function when you have the vertical asymptotes and the x-intercepts. Okay, that's kind of primarily what you need. But before I get into that, I want to just do some quick review of how you multiply binomials, or in this case, a binomial and a trinomial. And there's different ways of doing this, but the way I'm going to kind of show you is what we call box method, and this is just one way of doing it. I'm partial to something called FOIL, but I'm going to try and stick to one way, so that way I'm not throwing different methods at you. So you have x times x, which is x squared, x times negative 6, which is negative 6x, negative 1 times x, which is negative 1x, negative 1 times negative 6, which is a positive 6. Okay. So you have x squared and you have the 6. You add or subtract, in some cases, these two numbers together, so that your final equation would be x squared minus 7x plus 6. Okay. Same thing if I had these two right here, and again, I'm just going to do a quick, this is x plus 5 and this is x minus 5. Now, does it matter if plus 5 or minus 5 goes here? Not really. You'll get the same answer. X and x is x squared. X and negative 5 is negative 5x. X and 5 is 5x. 5 and negative 5 is negative 25. Again, you put these numbers together, so you end up with x squared minus 25. Okay, because 5 minus 5 becomes 0. And then you have something like this. Now, because this is a 3-term, okay, when I do the box, I want to make sure and make it large enough to accommodate the 3 terms. So you'd have x plus 2. Then you'd have x squared minus 4x plus 3. Okay. So here you have x times x squared, which becomes x cubed. X and negative 4x becomes a negative 4x squared. X and 3 becomes 3x. X squared and 2 becomes 2x squared. Negative 4x and 2 becomes negative 8x. 3 and 2 becomes 6. And then again, you have these two that you're going to put together, whether you add or subtract them. So you have x cubed minus 2x squared minus 5x plus 6. Okay, so it's a quick quick review of how you multiply binomials, or in this case, a binomial and a trinomial together, because this is something that we're going to do today also with this. Okay, so kind of give you an idea what you're looking at. We're looking at factored form and a standard form. This is kind of what your standard form is going to have, two polynomials that look like this. Okay. You have the zeros in the top, so your numerator become your x-intercepts. Okay, so your numerator or your x-intercepts, we call them zeros. Okay, and then your denominator become your vertical asymptotes. Okay, there is an a value, which I will talk about a little bit later on, that we use to denote a horizontal, but it's not always necessarily a horizontal. So I don't want to tell you that's the horizontal. Okay, sometimes it is, sometimes it isn't. But you have your two factors. This is called factored form. Then you have your standard form. We multiply the two factors to get this, multiply these two factors to get this. Now, here's kind of the key to this. We use the opposite values to write these. Okay, that's what we use to do this. Okay, so there's a couple of steps that, and again, I'm just kind of show you. Well, first we want to be able to identify the horizontal and vertical, and I'm going to show you how to do that. Okay, here in a second, because they're not always going to be given to you. Just letting you know. For our intensive purposes, we're going to be using whole numbers or halves. So there's something that looks like it's halfway or it's not on an actual line, then it's going to be a 0.5. Okay, or for our 1/2 fraction. We'll determine the zeros of the graph. Again, those will be wholes or halves depending on how it's written. And then we'll use all those to fill out this formula or this little kind of setup for you. If the the horizontal asymptote is not equal to 0 for these problems. So in other words, it's possible that if we have something other than 0, the a value is going to be that horizontal asymptote for these particular kinds of problems. It's not always the case, like I said a minute ago. We'll multiply to get your standard form, and then we'll check the y-intercept, and I'll show you what I mean by that here in a little bit. Okay. All right, so here's how it works. So notice one thing, there aren't any vertical lines here to show you where the vertical asymptotes are this time. Okay, that is a commonality in terms of what you might see, but I am going to show you how you can identify them by looking at the graph itself. And what you want to find or look for is essentially where the graph looks like it's going to kind of run into a wall here and here, because what that means is you have a vertical asymptote that sits right there where the two graphs are kind of meet like this. That's what you're going to be looking for. Okay. Sometimes they're not defined easily, so you have to really look to see, if the graph is going to hit here or here, then somewhere between them, there's a vertical asymptote, kind of like that. Okay, so that's kind of one of the first things you want to do is be able to identify those pieces right there. Now, in this case, this one looks like it's at 6. This one looks like it's at -2. So that's what I'm going to write for those two. Okay, actually, I'm going to write it right here because I just realized that. Okay. Next thing I want to do is I want to figure out my zeros or my x-intercepts. Well, I have one right here and I have one right here. Well, this one looks like this one is at 3, 0. This one looks like it's at -1, -2, -3, 0. Okay. So now what I'm going to do is I'm going to take these and I'm going to write the factors of these. So here's how it works. The general formula, if it's x minus, then the first one will be -2, which becomes x plus 2. So my first factor in my denominator is going to be x plus 2. I'm trying to make this a little bit closer so you can kind of see it a little bit better. Okay. So in my next one here, I have a 6. I'm sorry, you can't see that. I have a x equals 6. So again, if I write into my formula of x minus 6, which becomes my denominator. Okay, so your vertical asymptotes go into your denominator. Then I look at my zeros and I say, okay, if I have 3, which is the one I need, and I go into my equation, then my numerator should have an x minus 3 somewhere. Okay. If I have a -3 sitting there, then that means in my numerator, I should have an x plus 3. Okay. And again, if you're not sure why, because the formula, it literally says x minus 0. So if I do x minus a -3, that gives me x plus 3. That's the reason why. So now I've got my factors in factored form. Okay. Now to multiply this to get my final equation, and again, if you can do FOIL, you can do box, however you want to do it. X plus 3. This becomes x squared, 3x, -3x minus 9. So then your first part becomes x squared minus 9 on top, over. And in the bottom, and again, if I have this and do this, where it's x plus 2 and x minus 6, this is x squared minus 6x plus 2x minus 12. And again, I'm multiplying to get these numbers. So I have x squared minus 4x minus 12. And there's my final form. Now, how do I know that this is right? There's 2 ways you can look. One, if you look at your, what we call leading coefficients, there's a 1 here and a 1 here. Okay. If I do 1 divided by 1, that gives me a 1. That means that my horizontal should be at 1. And if you look here, it actually is. Okay, so it works nicely this way. Okay. Next thing I want to do is check my y-intercept. Well, if I look at my graph, there's a y-intercept that sits right here, and you can't really tell on mine, but it's actually right below the 1 line here. So it's a fraction of some sort. So here's what you do. You take your equation that you just got, and you look at the two numbers that don't have x values. This -9 and this -12. Well, -9 and -12 become 0.75, which I'm going to do a fraction on this, which is 3/4. So my y-intercept is going to be at 0 and 3/4 because of these two numbers right here. Okay. And there you have it. That's what we're looking at today, is how to write it from the factored form into the standard form. Okay. So now I'll put a couple of graphs here that you can try. And I will give you, a chance to look and see what you can do with them. Okay. I'll be back in a second. This is example 2 now. Okay, this is what this one looks like. Again, I have a vertical at -5 and a vertical at 0. Now, this -5 is a little bit harder to see, but the reason why I know it's here is because this graph comes down and it looks like it's going to run into a wall right in this area, which is at -5. And then 0 is the other one because this one and this one both run into that wall here and here. Okay. So my numerator, because this is a 2 at the x-intercept here, and this one's at 9, then this becomes x minus 2 and x minus 9 for these two guys. Because this is a +5, this becomes a -5, this becomes an x plus 5. And then the 0 becomes x minus 0. Now somebody will ask, do you have to put x minus 0? You really don't. But again, just to get used to it, you can. I do my multiplication here, and I get that this is x squared minus 11x plus 18, x squared plus 5x plus 0. Now, again, the question is, do I have to write the 0? Now, I write it here for a reason, and you'll see this in a second. So I check, is this correct? Well, of course, this is 1 over 1. So my horizontal is at 1, which looks correct based on the graph. Okay. Now, this one's a little bit harder to see because this one goes down and it comes back up. It actually comes back up to 1. Now, the second part is my y-intercept. Well, if I do 18 divided by 0, I can't divide by 0. Since I can't do it, that means that there is no y-intercept, which makes sense because I have a vertical asymptote at y equals 0, which is where the y-intercept would normally be. So therefore, there is no y-intercept, and it's also proof that 18 divided by 0 is not going to work in this case. Okay. All right. Example 3, again, try it again. I'll come back in a second. Okay, so this one's a little different, and what you notice I have it up here is the fact that your horizontal asymptote's at 0. So there's a special case of this that you have to be aware of, okay? So one, there is a vertical asymptote at 3, and again, this graph's going to bounce here, or not bounce, run into the wall here. This one will run into the wall here, which puts it at 3, okay? Then here's what happens. There are no x-intercepts if you look at the graph, and that's on purpose in this case. If that happens, then what we're going to do for the time being is this. Remember that a value I said won't have a significance until later on? Well, this is where it is, okay? Since we don't have any x-intercepts to write anything in our numerator, for the time being, we're just going to make that a value on top equal 1, and that's it. So your denominator, which is this x equals 3, becomes x minus 3 in your denominator. So your actual equation is, in this case, just 1 over x minus 3. Now, to do the y-intercept, we do the same thing still. We look at the 1, we look at the -3, and we know that the y-intercept is at 0 and -1 over 3. Okay. And that's mainly because your horizontal asymptote is right here at 0. And that does happen sometimes. So if you don't have an x-intercept and your horizontal intercept is y is a 0, for the time being, right now, we're just going to put a 1. Okay. And there are times when this is not a 1, but for right now, we're going to use a 1 on these. Okay. Okay. Now, I know this seems like a little bit long. It's just because I'm giving you different scenarios, trying to give you different scenarios. Again, here's another one where you have a horizontal at 0, but you do have an x-intercept this time. Okay. So try that, and we'll see what happens. Okay. Here's example 4. And again, you have a horizontal at 0, but you do have an x-intercept this time, which is doable. Now, again, I'm just going to reiterate, the horizontal only affects the end behavior of the graph, which is here and here. So it's okay to have an x-intercept so long as it's not the two ends of the graph like this. Okay. So x equals -3, x equals 6, a 0 or an x-intercept at 3, 0. So I'm going to write this. This is my numerator, so x minus 3. My denominator, so x plus 3. My denominator, so x minus 6. I multiply the bottoms, and I get x squared minus 3x minus 18. Okay? To check for my horizontal, there's no point because here's kind of the rule, and there is a rule to this. Because there's one term on top and two in the bottom in this case, your horizontal is going to be at 0 automatically. Okay? And I'll go more in detail about those rules later on, but that's just to know that right now. So there's no point in saying it's 1 because it's not. Okay, it's actually 0. But the y-intercept is still -3 over -18, which is 1/6. So your y-intercept is at 0 and 1/6. Okay, so what happens if your a value is greater than 1? And I'm going to show you what happens on this one. Okay, so try it, and then I'll come back in a second. Okay, so here's what happens. Again, vertical at 1. So my denominator is x minus 1. My 0 x-intercept is at 2. So x minus 2 here. Now, because this horizontal is at 3, and right now, if I don't have this 3, this shows that it would be 1 because it's 1 divided by 1. So in order to make this a 3, I have to make this a value in front a 3. And then distribute through. So that way, this, which is 3 divided by 1 now, which is what I want, is my horizontal asymptote at 3. So sometimes you'll have to make and add that number in front, which is where the a value comes into play. Okay. My y-intercept is in this case still 0, 6. -6 divided by -1. So there it is. So what happens when you don't have a graph and you're only told where things are at? Okay. So here's what I'm going to tell you. Here's kind of the rule of these. If it tells you, yeah, you have vertical asymptotes and zeros, we're going to treat it the same way like we did a minute ago. Okay. But there's one thing about fractions that you have to know, and it's just the way that you write them. Okay. So my asymptote would still be my denominator. My x0 would still be my numerator. So this 2, 0 would become x minus 2 in my numerator. Okay. And this denominator would become x minus 1/3 in my denominator. Okay. But here's the rule. We have to make sure and rewrite these, okay, from the fraction to a linear, into a more, without a fraction, let me put it that way. You have to write these without a fraction. And the way we do that is this. We take your denominator here and we bring it to the front. That's it. So if I rewrite this as my final equation, this is going to be x minus 2 over 3x minus 1. Okay. And then again, the rule still applies. -2 over -1 becomes my y-intercept in this case. We're not worried about horizontal asymptotes, but essentially, again, if you look, this is 1 over 3. So your horizontal asymptote would have to be 1/3. Okay. We'll get more into this as we move forward in this unit. So again, same thing. You have two vertical asymptotes. So here, in my denominator, I would have x minus 5/2. And then here I would have x plus 1 for this 2 right here. Then I have 1 at x minus 3 for the first 0 and x minus 5 for the second 0. So now I'm going to have to do some multiplying to get my final equation. So the top part, and I'm going to do this FOIL method just to kind of save a little bit of time, but I'm used to. But essentially, if I do x times x, that's x squared. X times -5 is minus 5x minus 3x plus 15. So my numerator would be x squared minus 8x plus 15. Okay. This one right here, I can't leave it like this to multiply. So I'm going to rewrite it as 2x minus 5. And then I can multiply x plus 1 to it. Okay. So 2x times x is 2x squared. 2x and 1 is 2x. Negative 5 and x is minus 5x. And then negative 5 and 1 is minus 5. I'm going to write out a rule. So my final bottom would be 2x squared minus 3x minus 5. Just like that. Okay. And again, my y-intercept, if I look here, 15 divided by negative 5 would be negative 3. So my y-intercept is at 0, negative 3. And then again, if I take one more step, this is 1 over 2. Well, y-intercept would be at 1 over 2. My horizontal asymptote would be at 1 over 2. Okay. You don't need to know that now, but I'm just kind of giving you kind of a preview of what's coming up. So here's example 8. Try it. Okay, that's what I got. And again, x minus 3/4, because this is 3/4 on top in your numerator. Minus 2, minus 1, minus 3. This becomes 4/3, so I have to rewrite it as 4/3. And then when I multiply them through, this is what I get for my numerator denominator. And then my y-intercept would be 6 over 3, which is 0, 2. Now, to finish this off, the reason why the y-intercept works like this is because that means I'm plugging in 0, 0, 0, 0, which means all of this goes away. So the only numbers I have left over are 6 and 3, which is where the y-intercept comes from. So, all right, that's all for the notes. I'm going to go over a few things for if you're interested in some of the advanced stuff that you see, like the holes and all that. If not, then you're done. But I'm going to kind of just finish this off real fast. Okay, so for one of the things you deal with are holes, and there's a rule of holes that I'm going to tell you, but basically this, you still treat everything else the same. Vertical asymptote would be at x equals 1. X-intercept would be at 2, 0. Now there's a hole, and there's a hole right there, okay? And that hole falls, I'm trying to remember where it falls now, because I did it earlier. It falls at negative 2 something. I don't remember what the next number is, and I'll show you how to find that in a second. But I need this first number anyway to do this. So here's what happens. When I write this as a factored equation, I still do it the same way. There's in my denominator is my vertical asymptote, which would be x minus 1. My numerator would be my 0, which would be x minus 2. Okay. In order to create this hole at negative 2, what you have to have is a factor on the top and the bottom that is the same. So if my hole is at negative 2 something, then my negative 2 would become an x plus 2 for my numerator and denominator. Okay, so you have to have both. Now, to figure out where the hole actually is, here's what you do. You take the part that's not the same, and you use that to figure out where it's at. And in this case, it becomes negative 4 over negative 3. So it's at negative 4 over negative 3. Okay, just like that. That's how you do the hole, where it's at. I'm sorry, negative 4 over negative 3, which is a positive 4 over 3. Duh. Okay. But that's kind of the rule. You have to have like factors in your numerator and denominator in order to create where the hole is at. Okay, that's kind of the key. So my final equation, and again, I'm going to multiply these through, would be x squared minus 4 over x squared plus x minus 2. I'm not going to go through the whole multiplying part just to kind of show you that. Okay. If by chance you end up with a line with a hole, which does happen sometimes, okay, then in order to write the equation for this, we have to have two things. One, we have to know where the hole is at again. And in this case, it's at negative 4 something. We don't know what it is. Okay. I don't have a vertical asymptote per se. Okay. And I do have a x-intercept at 5, 0. So here's what you have to do something like this. You have to know the equation of this linear line. And that means y equals mx plus b again. So if I do my rise and my run, what you find out is that my slope, or my m, is 1, and my y-intercept is negative 5. So the equation for this line particularly is y equals x minus 5. Okay, and that's important because that actually becomes one of your factors automatically. Okay. Now, remember I said a minute ago, when you have a hole, you have to have like terms. Well, if I know that my term here is at negative 4, then it means I have to have a factor of x plus 4 and x plus 4. Okay, that's just the given for this. You have to have two of the same kind for this. Now, I could figure out where the hole is at itself, because if I take whatever I don't, that's not the same, and I plug it in for that, that gives me a negative 9. So my hole is at negative 4, negative 9. Okay, and that's how it actually works. And my final equation, which I realized I didn't have a spot for it, becomes, I'm just going to write it right here, x squared minus x minus 20 over x plus 4. That's my final equation. And it looks, I'm getting a shine. Oh, that's not going to work. Whatever. Anyway, so there you have it. All right. We'll see you later.